So it's 6.02 times 10 to the 23rd. That's the number of atoms in a mole. And then there's going to be twice as many of them, so that's 1.2 times 10 to the 24 atoms. We can also ask how many grams of oxygen are in O2. Remember, if we look at the periodic table, oxygen has an atomic mass of 16. There's 2 of them, so it's 32 grams. Okay, I'm going to do some mole practice problems, and this is also going to be a focus of the homework, so pay attention here so that you know how to do the homework. And I just want to say too that it is, I think one of the mole is like very powerful, and because it's so powerful, I think that's one of the reasons it's confusing, because you can do a lot of different things with it, so that when you look at a problem, you have to recognize what you're trying to solve and what information you need to solve that. So our first example here, it says you need 0.5 moles of calcium carbonate for a chemistry experiment. Calculate the mass in grams, and this is something chemists need to do all the time, because if you have a bottle of calcium carbonate, it's pretty hard to figure out when you have 0.5 moles. The way you usually do this is you convert to grams, and then you can weigh out the number of grams that you need on a balance. Okay, so another problem. What is the mass percent composition of sodium in sodium phosphate? And in the same problem, the mass percent composition of phosphate in this compound. So first of all, we're just going to write down the components of this. And so the mass percent composition, so we need to figure out the mass essentially of each element, and then the formula mass of the whole thing. So sodium from the periodic table, 1 mole has a mass of 23 grams, and there's 3 of them, so that's 69 grams total of sodium. Phosphorus is 31 grams, and there's just 1 of them. And then oxygen is 16, and there's 4 of them, so that's 64 grams. When we add that all together, we have a formula mass of 164 grams. So in other words, if we had 1 mole of sodium phosphate, we'd have 164 grams of it. So now we have to, again, go back and read our question again. I always need to reread it at this point to know what I'm supposed to be solving for. So what is the mass percent composition of sodium? So that's what we're asked for first. The sodium percent composition, so basically we figure out that it's we have 69 grams of sodium, and then there's 164 grams is the total mass. So basically we're going to divide 69 by 164, and then since we want to make it a percentage, we're going to multiply 100 by 100, and that's 42%. So this compound is 42% sodium. Now as for the percent composition of phosphate, and you have to be careful here. Now phosphorus, P, is an element. Phosphate is one of those polyatomic ions that are in your table, and that is PO4, so it's the whole thing. So make sure that you look at what you're actually solving for, and be careful with names like this that are a little bit confusing. So phosphate has the phosp in it because it has phosphorus, but phosphate is PO4 and phosphorus is just P. So anyway, we want PO4% composition, and for this it is going to be basically what we do is add together the P and O, and that's 31 plus 64, or 95 grams, and then we're going to divide that by 164, so that's 58%. Now, the other way you could do this is you could have just, since it's only sodium and phosphate, if you took 100 minus 42, you get 58%. And then these two do add together, so you can also check your work. So it's 42% sodium, 58% phosphate. Okay, another problem, 0.6 moles of sodium phosphate dissolves completely in water to form sodium and phosphate ions. how many sodium ions are formed. So this is one of the cases we're talking about same substance, but we're going in a different direction where we want to figure out the number of ions formed. So for if we have one sodium phosphate molecule, it has three sodium ions that are going to be released when it dissolves. So that's 3 sodium ions. And then we can multiply that out. So if we have, we have 3 ions formed, and we started with 0.6 moles. So 0.6 times 3 is 1.8 moles of ion are formed. And again, let's look at what we're actually trying to solve here. So we know that we have 1.8 moles of sodium ions formed, but we want to know the exact number of ions, not the moles of ions, the exact number of ions. So to do that, we need Avogadro's number, which is 6.02 times 10 to the 23rd ions per mole. So notice it's like particles per mole. In this case, the particles are ions. In other cases, it might be atoms or molecules, but we're looking for ions here. And I arranged it so that ions is in top and moles cancels. And it turns out that we will have 1.1 times 10 to the 24 sodium ions are formed. All right, how many grams of carbon does a plant need to make 1.2 moles of sugar, which is C6H12O6? So this is a process of photosynthesis where plants produce sugar, which you'll learn about if you're taking biology. So anyway, if we have 1.2 moles of sugar, we want to know how many grams of carbon. So what do we need to do first? The first thing I like to do is write down what I know. So I know I have 1.2 moles of sugar. And then we want carbon. So we don't want grams of sugar, we want grams of carbon. So there's going to be 6 times as much because there's 6 carbon atoms in a sugar molecule. So 1.2 times 6 is 7.2 moles of carbon. So we're halfway there. Now we have 7.2 moles, and then we want to figure out the grams. And if from the atomic mass of carbon is 12, so 12 grams per mole. We write it that way so that moles cancel, and we end up with 86 grams. All right, right here I have a bunch more practice problems. I will go over these in a later review presentation, but I encourage you to do them yourself, because the more that you do these on your own, the easier they will be. And right here is the answer, so you can pause it and write these down as well. But again, I recommend you do them before you look at the answer and check to see if you got your work right. And that's all until next time.